Okay, so hello everyone. So do the live chat say hi to Madam. So we shall start our class tonight. So tonight our class will be on hydroxy compounds. Okay, it will be on hydroxy compound. So hydroxy compound. Okay, so hydroxy compound. So introduction, hydroxy compound basically refer to the compound with the functional group hydroxyl group. So all hydroxy compound, they will have the functional group hydroxyl group attached to somewhere. Okay, for hydroxy compound can be divided into two types. So one is called aliphatic alcohol. So what is aliphatic alcohol? So aliphatic alcohol basically the organic compound having at least one hydroxyl group attached to the alkyl group. So hydroxyl group attached to the alkyl group. And the general formula for aliphatic alcohol is CnH2n plus 1 OH. So like for this one, can you see that the hydroxyl group attached to this alkyl group? So this is aliphatic alcohol. Hydroxyl group attached to the alkyl group, so this is aliphatic alcohol. Hydroxyl group attached to the alkyl group, so this is aliphatic alcohol. So aliphatic alcohol, hydroxyl group attached to the alkyl group. Then what is aromatic alcohol? So aromatic alcohol, we have the hydroxyl group attached directly to the carbon of the benzene ring. Like for example, the hydroxyl group attached to the carbon of the benzene ring. So this is aromatic alcohol. So this is also aromatic alcohol because the hydroxyl group attached directly to the carbon of the benzene ring. So these two are examples of aromatic alcohol. So again, hydroxy compound, two types, aliphatic alcohol, hydroxyl group ikat kepada alkyl group. Aromatic alcohol, hydroxyl group ikat kepada carbon of the benzene ring. So now we move on to look at how to class hydroxy compound. So like haloalkane, hydroxy compound can also be classed based on the carbon where the hydroxyl group is attached to. Okay, like for example, this is the carbon that hydroxyl group attached to. If this carbon attached to semua hydrogen, then that is methyl alcohol. Okay, so if the carbon of the hydroxyl ikat kepada dua hydroxyl, means that satu alkyl group. So if one alkyl group, it is primary alcohol. So if the carbon of the hydroxyl ikat kepada one alkyl group, then we get primary alcohol. And then this is the reference carbon because they ikat kepada hydroxyl group. Can you see that having one hydrogen? So means that you have two alkyl groups. So if attached to two alkyl groups, that means that we get secondary alcohol. Okay, so again, this is the reference carbon ikat kepada no hydrogen. So means that attached to three alkyl groups. So three alkyl groups, then it is tertiary alcohol. Okay, so that is how we class hydroxy compound based on the carbon that is attached to the hydroxyl group. Tengok ada berapa alkyl group attached to it. So now we move on to look at the example. So in this example, how do we class the alcohol? Again, we need to look at the carbon where the hydroxyl group is attached to. Tengok carbon ini ada satu hydrogen. So if satu hydrogen bermasuk two alkyl groups, so if attached to two alkyl groups, that means that, so attached to two alkyl groups, so means that this is the secondary alcohol. Okay, we move on to look at the next example. So where is the reference carbon? So this is the carbon because this carbon attached to the hydroxyl group. Tengok carbon ini ada dua hydrogen. Kalau ikat kepada dua hydrogen, means that hanya ada satu alkyl group. So if only attached to one alkyl group, then this is primary alcohol. Then now we move on to look at the next one. So can you see that this hydroxyl group is attached to the carbon of the benzene ring? Kalau attached to the carbon of the benzene ring, this is aromatic alcohol. For aromatic alcohol, we can class it. This is aromatic alcohol, we can class it. Okay? So now we move on to look at how to name alcohol according to IUPAC nomenclature. So to name alcohol, first we need to determine the parent for alcohol. So how to determine the parent? Again, we need to look for the longest continuous carbon chain with hydroxyl group. And then when we want to name the alcohol, the alkane ANE at the back, the E at the back will change to OL. The E at the back of the alkane is changed to OL. So that is first step. We identify the parent. Cari dulu mana is the longest continuous carbon chain with the hydroxyl group. And then when we name the parent, the E of the alkane change to OL. And then second, we need to number the longest continuous carbon chain. So how do we number the longest continuous carbon chain? We need to start number, okay, in the way that the carbon of the atom, the carbon that attached to the hydroxyl group has the lowest possible number. So again, after identify the parent, when we want to number the longest continuous carbon chain, measure the carbon yang ikat kepada hydroxyl group has lowest possible number. Okay, and the positions of the hydroxyl group, we must indicate the number. Okay, so we must indicate the position of the hydroxyl group, okay, attached to which carbon on the parent chain. And then step number 3, then we can give the IUPAC name for the alcohol. So how to give the IUPAC name for the alcohol? So we need to name all the substituents present in the alcohol, okay, and also give their number, okay. And then if there are 2 hydroxyl group, we call it as diol. 3 hydroxyl group, we call it as triols. So now we move on to look at this example. So again, to name the alcohol, step number 1, we need to find the longest continuous carbon chain with hydroxyl group. So for the first example, where is the longest continuous carbon chain with the hydroxyl group? Can you see that? It's this one. And then we need to start number. We need to number in the way that the hydroxyl group, the carbon the hydroxyl group attached to has the lowest possible number, So how do we number it? We need to start from the right. Okay, so what is the name of this parent? So to name this parent, can you see that 4 carbon, so is butanol, but then this hydroxyl group is attached to carbon number 2. So we can call this 2-butanol, or we can also call this as butan 2O. Okay, so either way. Okay, so the 2 indicate the hydroxyl group attached to the second carbon of the parent. And then substituent, we have 4-chloro and also 3-methyl. To name this alcohol, again, alphabetical order. So chloro C and then methyl M. So chloro first, so we can call this compound as 4-chloro, 3-methyl, 2-butanol, or butan 2O. Then we move on to look at the second alcohol. So the second alcohol, can you see that this is so I shall draw like this. So this is the parent. So this is the parent, and then which carbon is number 1? So remember, when we want to number, the hydroxyl group must be lowest possible number. Therefore, the carbon that hydroxyl group is attached to is number 1. So this is number 2, 3, 4, 5. So can you see that this parent is 5, 6. So this parent is called cyclohexanol. Okay, this is called cyclohexanol. We don't need to put the 1 because the rules where the hydroxyl, the carbon, the hydroxyl group is attached to, it must be number 1 because the rules, lowest possible number for the carbon that is attached to hydroxyl group. Okay, so and then the substituent we have 2-nitro. Therefore, this alcohol is called 2-nitro cyclohexanol. Then now we move on to look at the third example. So the third example, so this is our parent. So again, carbon where the hydroxyl group is attached to is number 1. So this is number 2. So this parent is called ethanol. Okay, because only 2 carbon, so you don't need to put ethane 1O. You don't need to put. Okay, and this substituent, we have 1-phenyl. So you need to put 1 here because phenyl can be at the second carbon, but here is at the first carbon, so it's 1-phenyl. Therefore, the name of this alcohol is 1-phenyl ethanol. So now we move on to look at, so how about there are 2 hydroxyl groups. So again, find the longest continuous carbon chain with the carbon that is attached to the hydroxyl group. So we have 2 carbon total, so 1, 2. So for this one, so how to name this? So this is ethane 1,2-diol. Okay, because the hydroxyl group is attached to carbon number 1 and number 2. So ethane 1,2-diol. And now I move on to look at the second example. So where is the longest continuous carbon chain? So this is the one. Okay, again, measure lowest possible number for the carbon attached to the hydroxyl group. So here will be number 1, number 2, number 3. So this is propane 1,2,2-triol, because 3 hydroxyl group. Okay, so then we move on to look at the next one. So the next one, so this is the parent. So the parent, so remember hydroxyl group has higher priority than the carbon-carbon double bond. So this should be carbon number 1, number 2, number 3. Okay, so this parent is called, this parent is called, so can you see that this is propene? Okay, so propene, but then now we have alcohol, so propanol. Okay, so this is, so we should call it 2-propene. So because carbon-carbon double bond is between carbon number 2 and number 3. So propene, 2-propene. So, and then 1O. Or we can also call this, okay, this is straight away the name. Or we can also call this as prop 2-in-1O. Okay, so this is the IUPAC nomenclature for alcohol. Okay, so again, so if there are 2 hydroxyl group attached to the carbon, so we call this, so like for this one, this is carbon number 1, number 2. So ethane 1,2-diol or 1,2-ethane-diol. Okay, both is acceptable. Okay, like for this one, so the carbon number 1 will be this one, number 2. number 3. So we can call this propane 1,2-diol, or it can be 1,2-propane-diol. Okay, so like the third example here. So where is the carbon number 1? So number 1, number 2, number 3. So this is hydroxyl group attached to carbon number 1 and attached to carbon number 3. So this alcohol, we can call it propane 1,3-diol or 1,3-propane-diol. Okay, so the next one, so this one total 3 carbon. So 1, 2, 3. So this one we can call it propane 1,2,3-triol or 1,2,3-propane triol. Okay. So these are the general name for each of it. So the general name, not that important, but the IUPAC name you do need to know because it's in the syllabus. So now we move on to look at IUPAC nomenclature for phenol. So how do we name the phenol? So this one you have learned in benzene chapter. So for phenol, so first we need to find the parent. So this is the parent. So this is the carbon that is attached to the hydroxyl group. So now in phenol, the hydroxyl group is become part of the parent. So the carbon of the benzene that is attached to hydroxyl group, it should be number 1, number 2, number 3. So this substituent is ethyl. So therefore, this compound is called 3-ethyl phenol. Or we can also call it as methyl phenol. Okay, so now we move on to look at the second compound. So again, the parent is phenol. The carbon of the benzene where it is attached to a hydroxyl group is carbon number 1. So this is carbon number 2. So this is 2-bromophenol. Or we can also call it as orthobromophenol. And now we move on to look at the third example. So this is the parent, carbon number 1, number 2, number 3, number 4, number 5, number 6. Okay, so what substituent do we have? So this substituent, we call it as total 1, 2, 3, 4. So 4 carbon, and this is the third carbon, tertiary carbon. So therefore, this is 2 third butyl. Okay, so and then this one is 5-methyl. Remember, for third butyl, the third we do not take into account. We take into account the B. Okay, so of the butyl, and this is M. So which one comes first? B comes first. So therefore, this compound is called 2-third butyl 5-methyl phenol. Okay, so now we move on to look at, if given the name, how to draw the structure of the alcohol. So how to draw the structure of the alcohol. So I told you already, first draw the parent. So 1 propanol, so 3 carbon, so 1, 2, 3. So 1 propanol hydroxyl group at carbon number 1. Okay, and 2-methyl. So at carbon number 2-methyl, so this is CH2, so CH, CH3. So this is your 2-methyl 1-propanol. Okay, so we look at question number 2. Or before that, we also need to class the alcohol. So circle the reference carbon dulu. So this reference carbon has 2 hydrogen. So kalau 2 hydrogen bermaksud 1 alkyl group attached to it. So if 1 alkyl group, that means that this is primary alcohol. Then now we move on to look at question number 2. So question number 2, again, want to draw the parents first. So this is 2-butanol. 2 butanol. So butanol 4 carbon, 2 butanol hydroxyl group attached to carbon number 2. And on carbon number 2 also you have the phenol substituent. Okay, and then put in the hydrogen. So this is CH3, CH2, so already 4. So this one CH3. So look at the reference carbon, no hydrogen attached to it. So means that 3 alkyl group. So means that this is tertiary alcohol. Then now we move on to look at question number 3. So question number 3, the parent 4-pentene 2O. So pentene 5 carbon. Okay, between carbon number 4 and number 5, you have carbon-carbon double bond because pentene. Okay, and on carbon number 2, you have the hydroxyl group. So then now we can put in the hydrogen. So this one CH2 and this one CH. And then this one CH2. So this one CH. So CH3. So this one, what is the class? Circle the reference carbon first. Satu hydrogen. So kalau satu hydrogen means that two alkyl group. So 1, 2 alkyl group. So if 2 alkyl group, so this is secondary alcohol. So now we move on to look at example 4. So example 4, so how to draw the alcohol? Again, cyclopentanol. Cyclopentanol, so 5 carbon attached to hydroxyl group. So one of the carbon has the hydroxyl group. So this is carbon number 1. Number 2, number 3, so have the methyl group. So this is 3-methyl cyclopentanol. And what is the class? So again, circle the reference carbon. So carbon ini has satu hydrogen. So if satu hydrogen means that 2 alkyl group attached to it, so means that this is secondary alcohol. Then now we move on to look at the physical properties of alcohol. So for physical properties of alcohol tonight, I'm going to go through 3 physical properties of alcohol. So the first one, boiling point. So like other class of compound, the boiling point of alcohol is affected by molecular weight or molar mass. So still remember, when the molar mass increases, the surface area in contact between molecules increases. So therefore, the van der Waals becomes stronger and the boiling point increases. Okay, so if compare, so basically, if compared to the hydrocarbon, okay, if compared to the hydrocarbon, generally alcohol will have higher boiling point. So kenapa alcohol has higher boiling point compared to the hydrocarbon? It is because for alcohol, it has the hydroxyl group, which allowed it to form hydrogen bond between the alcohol molecule. When between the alcohol molecule can form the hydrogen bond, and we know that hydrogen bond is stronger than the van der Waals forces, therefore alcohol generally has higher boiling point than the hydrocarbon. So this is the first factor affecting the boiling point of the alcohol. So the second factor is the number of the hydroxyl group. So we know that alcohol, it can form, okay, let me draw like this. So basically, alcohol, generally it can form hydrogen bond between the molecules. So this is the hydrogen bond. Therefore, because between alcohol, they can form hydrogen bond, and hydrogen bond is stronger than the van der Waals forces. Therefore, alcohol higher boiling point than the hydrocarbon. Okay, and as the second factor, as the number of hydroxyl group increases, then more hydrogen bond can be formed between the alcohol molecule. So when more hydrogen bond can be formed between the alcohol molecule, then higher will be the boiling point. It's about stronger hydrogen bond between the molecule. Okay, and the third factor is branching. So we know that branching, so straight chain, larger surface area in contact, therefore higher boiling point. However, for the branch alcohol, when the alcohol have branch, so dia punya van der Waals forces, okay, so the van der Waals forces will become weaker because for the branch, so smaller surface area in contact. Therefore, straight chain alcohol, bigger surface area in contact, will have stronger van der Waals forces, so higher boiling point. Again, straight chain alcohol, higher boiling point compared to the alcohol with branch. Okay, because branching reduces the surface area in contact between molecule, weaker van der Waals forces, lower boiling point. So therefore, you will expect primary alcohol so straight chain, so higher boiling point compared to, for example, tertiary alcohol. So tertiary alcohol, because branching reduce the surface area in contact between molecule, so van der Waals forces weaker, lower boiling point compared to the primary alcohol. So, and then the second physical properties that we are going to look at is solubility in water. So remember, I taught you before, to be able to be dissolved or soluble in water, so that particular organic compound must be able to form hydrogen bond with water. Okay, so basically for alcohol that has less than 5 carbon, they are completely soluble in water. For alcohol with longer carbon chain, more than 5, they are insoluble in water. Why alcohol less than 5 carbon is soluble in water? Because for alcohol, again, to be soluble in water, it must be able to form hydrogen bond with water. And alcohol, it can form hydrogen bond with water molecule. Therefore, alcohol is soluble in water. Okay, the one that less than 5 carbon, so is soluble in water. So alcohol and water present due to the presence of the hydroxyl group, so they can form hydrogen bonding, therefore soluble in water. However, for alcohol, the solubility in water also determined by the hydrophilic character. So this hydrophilic character is determined by the hydrocarbon chain. So this is the hydrocarbon chain. So, for example, if we have 1 propanol, so this is the hydrocarbon chain. And this hydrocarbon chain is basically hydrophobic. Hydrophobic means that scared of water. Okay, so hydrophobic. So basically for alcohol, it has hydrophobic part, which has poor interactions with water, and also the hydrophilic part, which can form strong hydrogen bond with water molecule. So this hydroxyl group, hydrophilic part, allow the alcohol with less than 5 carbon to be soluble in water. However, when the alcohol with more than 5 carbon, then the hydrophobic part become larger. So become larger, therefore it becomes insoluble in water. So again, there are two factors affecting solubility of alcohol in water. So the first one is molar mass or molecular weight. So as the molecular weight increases, the hydrophobic area becomes larger. So the solubility in water decreases. Like for example, if we have ethanol and also we have 1-hexanol. Can you see that for 1-hexanol, larger molecular weight, so larger hydrophobic area. So this hydrophobic area, so is larger in 1-hexanol compared to in ethanol. And this hydrophobic area, as it becomes larger, the solubility in water for that particular alcohol becomes less. It becomes less soluble in water. Remember, this hydrophobic area is having weak interactions with water molecule, Therefore, larger the hydrophobic area in 1-hexanol causes 1-hexanol to have lower solubility in water compared to ethanol. And the second factor affecting solubility in water is the number of hydroxyl group. So as number of hydroxyl group increases, the solubility in water increases because able to form more hydrogen bond with water molecule. Like for example, if we have ethane 1,2-diol, so ethane 1,2-diol has 2 hydroxyl group. So if having 2 hydroxyl group compared to ethanol, only 1 hydroxyl group. So ethane 1,2-diol having 2 hydroxyl group, so means that can form more hydrogen bond, with water. So when can form more hydrogen bond with water, means that this ethane 1,2-diol is more soluble in water compared to ethanol. Okay, only have 1 hydroxyl group, so can form less. So I should write can form more hydrogen bond. This one, less hydrogen bond with water, therefore less soluble in water. Okay, so now shall we move on to look at the exercise? So exercise, so shall we have a look on this exercise? So the question asks you to arrange the compound in ascending order of boiling point. Okay, so how to do this? Can you see that their molar mass almost the same? So means that it's not the molar mass that determine the boiling point. There will be the strength of intermolecular forces that is going to affect the boiling point of this organic compound. So this is alkane. So alkane is non-polar. So last semester you have learned, so if non-polar, it is only having London dispersion forces. Okay, so this one is weak van der Waals forces. Then now we move on to look at alcohol and also our haloalkane. So they are all polar molecule. Okay, but for alcohol, they have hydroxyl group. So when they have hydroxyl group, means that beside dipole-dipole forces and London dispersion forces, they can also form hydrogen bond While for haloalkane, there is no hydroxyl group. So if no hydroxyl group, it is polar. So means that between haloalkane, you have London dispersion forces and also the dipole-dipole forces. So you have stronger van der Waals forces. Okay, so for alcohol, besides having the London dispersion forces and dipole-dipole forces, they can also form hydrogen bond between the molecule using the hydroxyl group. They can also form the hydrogen bond between the molecule. Okay, however, can you see that this is diol? This is diol. So diol means that it has more hydroxyl group. Remember, if more hydroxyl group means that it can form more hydroxyl group, so means that form more hydrogen bond between the molecule compared to the first compound which only having one hydroxyl group. So with that, then we can arrange the compound in ascending order of boiling point. So the lowest one will be the alkane. So this is pentane, followed by our haloalkane. Followed by the alcohol with one hydroxyl group. Followed by the alcohol with two hydroxyl group. So two hydroxyl group can form more hydrogen bond between the alcohol molecule, therefore higher boiling point. So don't forget to draw the arrow and then write ascending order of boiling point. Then now we move on to look at, so just now they do not ask you to explain, so shall we move on to look at exercise number 2. So ask us to arrange the increasing order of boiling point. So use the same concept, So this is alkane. So non-polar. So higher under London dispersion forces. So lowest boiling point. Then move on to look at 1,2-ethanediol. So 1,2-ethanediol, 2 hydroxyl group. And then 1 propanol, 1 hydroxyl group. And then propane, 1,3-diol. There are 2 hydroxyl group. So followed by which one? So these 3, they are all polar. Okay, and all of them can form van der Waals forces and also hydrogen bond. So van der Waals forces and hydrogen bond. Van der Waals forces and hydrogen bond. But which one will be, so we know that N-butane is the lowest. So followed by which one? So it will be 1 propanol because only 1 hydroxyl group. And then between 1,2-ethanediol and 1,3-ethanediol, which one will be lower boiling point? So it will be 1,2-ethanediol. So why? Because the molar mass factor, 1,2-ethanediol only having 2 carbon, while 1,3-propanediol having 3 carbon. So bermaksud dia punya molar mass 1,3-ethanediol, molar mass higher, so higher boiling point. So how to explain this? Oh, okay. So basically, so can you see that what factors have we determined? So we have determined that the molar mass factor, so between these two, this is the molecular weight factor. And then between this, the number of hydroxyl group. And then between this, basically polarity of the molecule. So these are the three factors that we have determined. So we need to write it in our explanation. So generally, the boiling point increase as the strength of the van der Waals forces increases. Okay, so from N-butane, so this is only weak van der Waals forces. 1-propanol, we have stronger van der Waals forces and hydrogen bond. Okay, so and then the van der Waals forces increases with the increase in molecular weight. So means that between ethane 1,2-diol and 1,3-propan-diol. Okay, and hydrogen bond is stronger than the van der Waals forces. Therefore, 1-propanol is having higher boiling point than the N-butane. So that is a general statement. So how to explain this in specifically? Okay, so basically, so we already identified the factor. So number of the hydroxyl group. So basically, so which of the three compound having the hydroxyl group? So it will be 1,2-ethane-diol, 1-propanol, and 1,3. Oh, sorry. Two hydroxyl group. So 1,3-propan-diol have two hydroxyl group. So hence they can form same number of hydrogen bond, but 1,3-propan-diol has higher molecular weight compared to 1,2-ethane-diol. Therefore, 1,3-propan-diol can have stronger van der Waals forces, therefore has the highest boiling point. Remember, this one is the lowest, followed by this. So number 4, highest boiling point, 1,3-propan-diol. Why highest boiling point? Because larger molecular weight, larger molar mass. This is 3 carbon. This is only 2 carbon. So larger molecular weight, so stronger van der Waals forces, so highest boiling point. Okay, while for 1-propanol only have one hydroxyl group. So if having one hydroxyl group only, so bermaksud sekarang it can form fewer number of hydrogen bond. Okay, if fewer number of hydrogen bond, so means that weaker van der Waals forces, so therefore lower boiling point compared to 1,2-ethane-diol dengan 1,3-propan-diol. Okay, and then which one has the lowest boiling point is N-butane. So why lowest boiling point? Because it is a non-polar molecule, only have the weak London forces, weak van der Waals forces, the London dispersion forces. Cannot form hydrogen bond between molecules, that's why lowest boiling point. So that is how you explain specifically. So you can explain N-butane, lowest boiling point, because only can form London dispersion forces between molecules, weak van der Waals forces. Okay, while 1-propanol only have one hydroxyl group, so form less number of hydrogen bond, so lower boiling point compared to 1,2-ethane-diol and 1,3-propan-diol. And for 1,3-propan-diol, higher boiling point because higher molecular weight, therefore stronger van der Waals forces, highest boiling point. So now we move on to look at solubility in water. So remember, solubility in water determined by the number of hydroxyl group and also the molecular weight. So for this one, 1, 2, 3, 4, 5, 6 carbon. So 1, 2, 3, 4, 5, 6, 6 carbon. So 1, 2, 3, 4, 5, 6, 6 carbon. So it's not the molecular weight, the factor. Okay, therefore, the solubility in water for this question is determined by number of hydroxyl group. So as the number of hydroxyl group increases, more hydrogen bond can form with water molecule, so more soluble in water. So which one is the most soluble? So it will be C, because having 3 hydroxyl group, so can form most number of hydrogen bond with water. So followed by, okay, B, because having 2 hydroxyl group, so can form less number of hydrogen bond compared to C, with water compared to C. And then A, only having 1 hydroxyl group, so the least number of hydrogen bond can be formed with water molecule, so the least soluble in water. So decreasing order of solubility in water. So now we move on to look at how to explain this. Okay, so again, this one is hexane, no hydroxyl group. So first we look at the number of carbon. Can you see that all 6 carbon, and this one is just 2 carbon? Okay, but this one no hydroxyl group, this one 1 hydroxyl group, and this one 2 hydroxyl group. Okay, so means that 1, 2, so 1, 2 ethanediol is the most soluble because it has 2 hydroxyl group. Therefore, can form more hydrogen bond with water molecule compared to 1 hexanol, which only have 1 hydroxyl group. Oh, I haven't arranged yet. So how to arrange? So 1, 2 ethanediol, the most soluble because having 2 hydroxyl group. Followed by 1 hexanol, only 1 hydroxyl group. And then hexane, no hydroxyl group. So this is the decreasing order of solubility in water. Okay, so and then for hexane, it does not have hydroxyl group in the compound, so it cannot form hydrogen bond with water molecule. Therefore, it is insoluble in water. Yeah, for hexane, it is insoluble in water. So the least soluble in water among these 3. So now we move on to look at the third physical properties of alcohol. So in your notes, can you turn to page number 30? So acidity is in page number 30 of your lecture notes. So could you please turn to page number 30 to look at the acidity of alcohol? So basically, between alcohol, water, phenol, and carboxylic acid, so they are all acid. They are all acid. So if acid means that they can donate the hydrogen, they can donate the hydrogen ion, they can donate the proton or hydrogen ion. And then whatever that makes the conjugate base form, okay, stable, it will make the acid more acidic. Okay, so remember, okay, so for example, remember this alcohol, it is acidic. So acidic means that it can donate the hydrogen ion, giving you the conjugate base. So basically, whatever that make the conjugate base stable will cause this acid more acidic. So conjugate base stable, then higher the acidity. So more stable is the conjugate base, then it is more acidic, the acid. Okay, so basically between carboxylic acid, phenol, water, and alcohol, carboxylic acid is the most acidic, followed by phenol, followed by water, and the aliphatic alcohol. So this is aliphatic alcohol. It is the least acidic. Okay, so why? So we are going to look at explanations in detail. So basically, to determine whether that particular acid is acidic or not, so we have seen we need to look at the conjugate base, whether it is stable or not. So what can affect the stability of conjugate base? So basically, there are two factors affecting the stability of the conjugate base. So the first one is called resonance effect. So what is resonance effect? So resonance effect, so basically refer to the negative charge. So negative charge on the conjugate base. So this negative charge on the conjugate base, if it can be delocalized into the pi system, then the conjugate base ion will be stable. So if it can be delocalized into the pi system, for example, benzene ring, then the conjugate base ion is stable. Okay, so the second effect that can affect the stability of conjugate base is called inductive effect. So inductive effect, so you have seen inductive effect before. Basically, it can be divided into two groups, electron donating group and also electron withdrawing group. So electron donating group, so basically, example, alkyl group, it will give away electron to the oxygen, give away electron to the oxygen. So therefore, will cause the conjugate base ion to be destabilized. Electron donating group, example, alkyl group, will give electron to the oxygen. This oxygen negative charge, sudah kaya electron, already electron rich. Alkyl group nak bagi dia lagi, so therefore destabilize the conjugate base. Okay, but if we have halogen, so like for example this one, like for example, if it is attached to halogen, so this halogen, okay, so basically it can pull away the electron. It can pull away the electron. Halogen is electron withdrawing group. Electron withdrawing group means that pull away the electron to itself. Okay, pull away people's electron to itself. So when pull away, then it can reduce the electron density on this oxygen, therefore can stabilize the conjugate base. Then therefore increase the acidity of the acid. Okay, so if we have electron withdrawing group, then the acid will become more acidic because electron withdrawing group can stabilize the conjugate base. So now we look at one by one. So we look at the carboxylic acid first. So carboxylic acid is an acid, so can donate the hydrogen ion. So donate the hydrogen ion become carboxylate ion. So this carboxylate ion is conjugate base. So to know whether carboxylic acid is acidic or not, we need to look at the conjugate base. So is this conjugate base stable? Yes, it is stable. So why is it stable? So basically, carboxylic acid is the most acidic. So kalau most acidic means that the conjugate base is most stable. So why the conjugate base is most stable? It is because this negative charge of on the oxygen can be delocalized into the pi system of the carbonyl group, okay, of the carboxyl group, okay, and then it can be delocalized between the two very electronegative oxygen atoms. So basically, the conjugate base stabilized by the resonance effect. Therefore, carboxylic acid is the most acidic. Kenapa conjugate base dia stabil? Stabil by resonance effect. So what is the resonance effect? Delocalization of the negative charge on oxygen between the two very electronegative oxygen atoms. So now I want to show you how does it delocalize. So basically this negative charge, delocalize means that it can move between the two electronegative oxygen atoms. So how can it move? So it can move inside here to form bond, and then when form bond, this bond must break. So to give you two resonance structure. So basically, by moving the negative charge into the pi system here, it stabilizes the conjugate base. It stabilizes this ion. Okay, so since this ion is stable, therefore carboxylic acid is the most acidic. Okay, so again, so carboxylic acid most acidic. Kenapa? Because the negative charge on oxygen can be delocalized between two very electronegative oxygen atoms. So means that the carboxylic ion, the conjugate base, is stabilized by the resonance effect. Therefore, carboxylic acid is most acidic. Then now we move on to look at phenol. So phenol less acidic compared to carboxylic acid. So why is it less acidic? It is because the negative charge. So again, phenol acidic. So bermaksud dia boleh derma the hydrogen ion to give us phenolcyde ion. This phenolcyde ion is the conjugate base. So phenol less acidic than carboxylic acid means that conjugate base of phenol, phenolcyde ion, is less stable compared to conjugate base of carboxylic acid. So kenapa less stable? It is because in phenolcyde ion, the negative charge ini can only be delocalized into the pi system of benzene ring. Okay, so means that it can be stable by resonance effect but less compared to carboxylate ion. So shall we look at how the negative charge on the oxygen atom delocalize into the pi system of benzene ring? So basically the negative charge here, so this electron move into to form the double bond. And then this pi electron bergerak ke sisi. So to give you so this is the resonance structure. And then this negative charge then can be delocalized inside. And then to give you another resonance structure. So you form double bond, negative charge. So this negative charge can be delocalized inside from here. So these are the resonance structure for the phenolcyde ion. Can you see that the negative charge semua ini is on carbon of the benzene? Is on carbon of the benzene. Carbon less electronegative compared to oxygen. While in the carboxylate ion, the negative charge is on oxygen. So as oxygen more electronegative, so more effective in stabilize the conjugate base compared to the benzene ring. Therefore, carboxylate ion is stabilized more by resonance effect compared to phenolcyde ion. Then now we move on to look at water. So water, acidic, bermasuk derma the hydrogen ion, so give you hydroxide ion and hydrogen ion. So basically hydroxide ion ini, this is the conjugate base. So water is more acidic than the aliphatic alcohol. Why? Because if we look at the hydroxide ion, there is no alkyl group to destabilize the hydroxide ion. Okay, so now we move on to look at aliphatic alcohol. So aliphatic alcohol is the least acidic. Why is the least acidic? Because, sorry, this is not hydroxide ion, this is alkoxide ion. The alkoxide ion is not stable. Why the alkoxide ion is not stable? So aliphatic alcohol is acid, derma hydrogen ion bagi kita alkoxide ion. So this is the conjugate base. And this conjugate base is not stable because alkyl group ini derma elektron kepada oksigen. Oksigen ini sudah sangat kaya elektron, negative charge. And then this alkyl group nak bagi dia elektron lagi, make it even more unstable. Okay, so because of that, your aliphatic alcohol, the least acidic, it is because of the alkyl group. This is the alkyl group on the alkoxide ion, increase the electron density on oxygen, therefore make the alkoxide ion less stable compared to hydroxide ion. Okay, that's why aliphatic alcohol, the least acidic. So then now we move on to look at identifications test for aliphatic alcohol. So it's on page number 25 in your lecture notes. Page number 25 in your lecture notes. So just now we have seen aliphatic alcohol. So we can class it into primary alcohol, secondary alcohol, and also tertiary alcohol. So any chemical test that we can use to differentiate mana adalah primary alcohol, mana secondary alcohol, mana tertiary alcohol, yes, there is a chemical test that we can perform. And that chemical test is what we call as Lucas test. So Lucas test is to use to differentiate different classes of alcohol. Okay, so in your syllabus, there are two chemical tests for aliphatic alcohol that we are going to learn. So the first one is Lucas test to differentiate different classes of alcohol. The second chemical test is called Iodoform test. Iodoform test basically is to identify adakah methyl carbinol group. So this is methyl carbinol group. Again, how to draw methyl carbinol group? We have methyl carbinol is C, satu belah OH, satu belah H, and here can be attached to anything. So this is methyl carbinol group. We can use iodoform test to identify whether methyl carbinol group is present in the aliphatic alcohol. So we look at the Lucas test first. So Lucas test can be used to differentiate primary, secondary, and tertiary alcohol. Okay, so basically Lucas test, the reagent is HCl and zinc chloride. Okay, HCl and zinc chloride basically make the reaction more susceptible to SN1. So remember, reactivity towards SN1 depends on the stability of carboxylic ion. Therefore, we will expect tertiary alcohol, which can form tertiary carboxylic ion, to be more reactive towards Lucas reagent, because Lucas reagent more prone to lebih cenderung kepada SN1 reaction. So tertiary alcohol can form tertiary carboxylic ion, lebih cenderung bertindak balas with your Lucas reagent. Okay, so basically in the Lucas test, what is happening is substitutions reaction. So substitutions reaction. So basically what is happening is halogen ganti the hydroxyl group. So this hydroxyl group diganti oleh halogen to give you your product. Okay, and this OH then combine with H to give you water as the byproduct. So that is the general reaction for Lucas test. So, and then again, I told you already, Lucas reagent lebih cenderung kepada SN1, lebih cenderung kepada SN1, and tertiary alcohol can form tertiary carboxylic ion. Therefore, we will expect tertiary alcohol most reactive towards Lucas reagent, and we can see that from the observation. So tertiary alcohol, immediately we get the cloudy solution, and this cloudy solution basically is your product. So tertiary alcohol boleh proceed through SN1 dengan cepat. Therefore, it will give you cloudy solutions formed immediately, okay, or appears immediately, okay. And secondary alcohol bagi kamu less stable secondary carboxylic ion. Therefore, tengok product form within 5 to 10 minutes. Okay, for primary alcohol kalau proceed through SN1, it will give you primary carboxylic ion that is not stable. Okay, because of that, Lucas test we do it in the durations of 10 minutes. Sebab primary alcohol will give primary carboxylic ion not stable. Because of that, even after 10 minutes of reaction with heating, we still do not get the product. We do not see the solutions turn cloudy. Okay, and for phenol, it does not react with Lucas reagent at all. Okay, again, Lucas test to differentiate different classes of alcohol. Okay, Lucas reagent, okay, is lebih cenderung to SN1. So paling cepat dengan tertiary alcohol. So you get cloudy solutions formed immediately. Followed by secondary alcohol, you get the solutions turn cloudy within 5 to 10 minutes. Paling lambat dengan primary alcohol. After 10 minutes, masih lagi the solutions doesn't turn cloudy. Okay, tak dapat product lagi. Even after 10 minutes. So phenol does not react with Lucas reagent. So now we shall look at for the Lucas test. So Lucas test, so to know whether the reactions occur or not, again first we need to class the alcohol. Like for this alcohol, can you see that 2 hydrogen bermasuk satu alkyl group, so this is primary alcohol. Remember, Lucas test we do it in 10 minutes. So primary alcohol after 10 minutes tak dapat product lagi. So if tak dapat product lagi, in the equations we write no observable change. Observation. So remember, product is the cloudy solution. So after 10 minutes for primary alcohol, even with heating, we do not get the cloudy solution. So the observation, so the solution does not turn cloudy even after 10 minutes heating. Remember, if the question asks about chemical test, we need to have the name of the chemical test, reagent mesti ada, and the equation together with the observation. So these 4 things you must have: chemical test name, reagent, equation, and also the observation. Okay, so now we move on to look at number 2. So again, to know whether you get product or not, you need to ask yourself what class of alcohol is this. So this one with 1 hydrogen means that 2 alkyl group. So this is secondary alcohol. So secondary alcohol reactions occur, okay, within 5 to 10 minutes. So kalau occur, pemasuk OH ini akan diganti oleh Cl. So your product will be Cl here. Okay, and then the OH yang keluar ini gabung with the H to give you byproduct water. So this product ini is the one that give you cloudy solution. So since that you can get the product and this is secondary alcohol, so how do we write the observation? So we write solution turns cloudy within 5 to 10 minutes. Okay, so that is number 2. Then now we move on to look at number 3. So look at this. This is our reference carbon, no hydrogen, so 3 alkyl group, tertiary alcohol. So tertiary alcohol, remember Lucas reagent, SN1. So tertiary alcohol, tertiary carboxylic ion paling cepat the substitution reaction occur. So substitution Cl masuk ganti the OH. Cl masuk ganti the OH. So we get the product, this. And the byproduct OH combined with the H, giving you water as the byproduct. So tertiary alcohol will be most reactive towards Lucas reagent. Therefore, we see the product form immediately. So observation, we write solution. Okay, we can write a cloudy solution forms immediately. So straight away you get the product. So again, chemical test, we need to have the name of the chemical test, reagent, equation, and observation. So done with Lucas test. So Lucas test to differentiate different classes of alcohol. For iodoform test, we want to detect the presence of methyl carbinol group. So this is methyl carbinol group. So this is methyl carbinol group. Okay, so methyl carbinol group. So basically, for iodoform test, the reagent is iodine in alkaline solution. And the observation, we see yellow precipitate. So this yellow precipitate is iodoform or triiodomethane, CHI3. Okay, so basically what is happening is in the iodoform test, so what is happening is this methyl group, it will leave. And this methyl group, when it leaves, it will give you CHI3. So it will give you CHI3. Okay, it will give you CHI3. So this methyl group akan pergi. The methyl group of your methyl carbinol group, dia akan pergi giving you CHI3. And this CHI3 is triiodomethane or iodoform, is the one that give you the yellow precipitate. So this yellow precipitate is the CHI3. So yang tinggal punya ini, it will be oxidized to give carboxylic acid. Tapi this is in alkaline condition. So alkali react with acid, bagi kamu garam. So which is your carboxylic ion. Okay, which is your carboxylic ion. So now, shall we move on to look at the example? For iodoform test, first, kita kena cari dulu. So first, kita kena cari dulu ada tak methyl carbinol group. So like for this one, this is the methyl. So the methyl carbinol group, methyl of the methyl carbinol group akan pergi bagi kita CHI3. So this is the yellow precipitate form. Then yang tinggal ni, it will be oxidized bagi kamu carboxylic acid. Tapi because in alkaline condition, bagi kita ion, carboxylate ion. Okay, so the next one, other than methyl carbinol group. Yes, this is the methyl carbinol group. So the methyl of the methyl carbinol group akan pergi dulu bagi kita CHI3. So that is the yellow precipitate. And then the remaining part will be oxidized, become carboxylic acid. So tinggal CH3, CH2, C double bond O, OH. But because this is alkaline condition, kita dapat carboxylate ion. So now we move on to look at the next one. Tengok yang ini, tak ada methyl carbinol group. So if no methyl carbinol group, it cannot react with iodine and NaOH. So if cannot react with iodine and NaOH, then we get no observable change. In the equations, we write no observable change. And then observations, we write no yellow precipitate form. Okay, so for iodoform test, reagent dia adalah iodine in alkaline condition. Okay, not necessarily NaOH, but it need to be alkaline condition. Okay, so now we move on to look at example question. So how can we differentiate 2-methyl 1-propanol from 2-methyl 2-propanol? So we can draw first. So propanol, 3 carbon, 1 propanol. So 2-methyl. So CH3, CH, CH2. So can you see that carbon ini mempunyai 2 hydrogen, so 1 alkyl group. So this is primary alcohol. So for 2-methyl 2-propanol, kita lukis dulu. Can you see that this is carbon ini, no hydrogen, 3 alkyl group, tertiary alcohol. So if different classes of alcohol, what is the chemical test that we can use to differentiate them? So Lucas test. So first one, you kena tulis dulu the chemical test, Lucas test. Then Lucas test, we need to use the reagent. So what reagent that we can use? So remember Lucas test, the reagent is concentrated HCl with zinc chloride. And then what is happening is substitution reaction. Yang ini primary alcohol. Primary alcohol, Lucas test buat dalam 10 minit sahaja. Remember, Lucas reagent, SN1, 10 minit tidak cukup. So, we get no observable change. And the observation will be solution does not, so we get no product, so bermaksud does not turn cloudy. Even after 10 minutes heating. So I told you already, for chemical test, we must have the name of the chemical test, reagent, equation dengan observation. So kita sudah buat untuk 2-methyl 1-propanol. We also need to do the same for 2-methyl 2-propanol. I don't have enough space, so I write here. So react with Lucas reagent. So this is tertiary alcohol substitutions reaction boleh berlaku di mana Cl ganti the OH, so you get the product. And the byproduct water. So you get product being formed, and this product is the one that gives you cloudy solution. This is tertiary alcohol. So basically the observations will be a cloudy solution forms immediately. Terus dapat. Okay. So now we move on to look at the next example. So the next example, we have benzene. Benzene. And also cyclohexanol. So what chemical test we can use to differentiate them? So you learn Lucas test and also the Iodoform test. Iodoform test mesti mempunyai methyl carbinol group. Yang ni tak ada methyl carbinol group. Okay, so means that we can only use Lucas test. So Lucas test, shall we look at this alcohol? This is a secondary alcohol. Okay, so secondary alcohol, dia boleh bertindak balas dengan the Lucas reagent, therefore will give you positive result. This one negative result. Okay, so shall we see? Benzene, Lucas reagent is concentrated HCl, zinc chloride. Yang ni tak ada reaction, so we write no observable change. So observation will be solution. So tak ada product, so solution does not turn cloudy even after 10 minutes heating. Then how about cyclohexanol? So cyclohexanol, again, ini Lucas test, kita kena guna Lucas reagent. So Lucas reagent basically substitution reaction, Cl ganti the OH. So we get the product, byproduct water. So what is the observation? So this is secondary alcohol. So reaction tak begitu cepat, tapi ada reaction. So remember, solution turns cloudy within 5 to 10 minutes. Okay, so that is Lucas test. So now we move on to look at how about if phenol. So turn to page number 35. So how can we differentiate phenol from other classes of compound? So macam mana kita nak bezakan phenol from other classes of compound? So basically there are two chemical tests that you can do. So the first one is test using iron 3 chloride solution. So phenol, when you react it with iron 3 solution, what you get is a purple complex. So observation, you see a purple complex form. Okay, or you can test it with bromine water. So test it with bromine water. So bromine water is reddish brown color. Okay, so what is happening is this bromine water boleh bertindak balas dengan phenol at 246 position. At 246 position. So to give you 246 tribromophenol. So kenapa boleh berlaku kat 246 position? So basically tadi kita sudah tengok delocalizations of the lone pair. Yang ni boleh bergerak masuk at 2, at second carbon, fourth carbon and the sixth carbon, the negative charge. So because of that, electrophilic aromatic substitution of phenol boleh berlaku at 246 position to give you 246 tribromophenol, and that is white precipitate. Okay, so the observation when you test it with bromine water is you see the reddish brown color of bromine decolorized and the white precipitate form. So now shall we look at, so again, for phenol, 2 chemical tests to differentiate phenol from other classes of compound. So the first one is test using iron 3 chloride solution. Kamu dapat purple complex. So the second one is you test it with bromine water. You get the white precipitate. 246 tribromophenol, the white precipitate. So now we move on to look at suggest a chemical test to differentiate phenol from benzyl alcohol. So phenol, so this is phenol, and also benzyl alcohol. So how to draw benzyl alcohol? So benzyl alcohol is like this. Remember, CH2, so OH. So this is benzyl alcohol. So what chemical test that we can use to differentiate phenol and benzyl alcohol? You baru belajar. So pilih salah satu. So shall we choose test with or using FeCl3 solution? So write the chemical test name first. So if we react with FeCl3, so for phenol, we get purple complex form. But for benzyl alcohol, so observation, we get purple complex. So this is the purple complex. So the purple complex forms. While for benzyl alcohol, we don't get the purple complex form. We get no observable change. So observation, we see no purple complex form. Then now we move on to look at, so again, always check. So chemical test, we must have the name of the chemical test, reagent, equation, observation. Name of the chemical test, reagent, equation, and the observation. So we have all the 4 things. Yeah, we get full marks. Then now we move on to look at the second question. So a chemical test to differentiate 1,2-ethanediol. So 1,2-ethanediol from phenol. So just now we used the test using FeCl3 solution. Now we change. We use another one, test with bromine water. So bromine water, reagent must be the same. So for 1,2-ethanediol, it will not react with bromine water. So not reacting with bromine water, you get no observable change. And this bromine water is reddish brown in color, reddish brown in color. So if you don't get the product, means that you still see the reddish brown color. It is still there. So means that you write reddish brown color of bromine remains unchanged. And no reaction, so you don't see the white precipitate. So no white precipitate formed. How about phenol? So for phenol, okay, remember it can react at 246 position. Okay, it can react at 246 position to give you 246 tribromophenol. And this 246 tribromophenol is the white precipitate. So means sekarang bromine water sudah ditindak balas become bromine dekat sini. So means that it is no longer reddish brown color. So you write reddish brown color of bromine decolorizes. And then this is the one that give you the white precipitate. So you write white precipitate forms. Okay? So, and again, we check. So chemical test must have the chemical test name, reagent, equation, observation. Chemical test name, reagent, equation, observation. Yeah, we get full marks. So summary, what have you learned tonight? So summary. So tonight we look at the physical properties. So for physical properties, we have looked at the boiling point. So boiling point, remember 3 factors affecting the boiling point of alcohol. The first one, molecular weight. So the second one, number of hydroxyl group. And the third one, branching. Okay. So, and then remember molecular weight increases, the surface area in contact increases when the wall forces stronger, higher boiling point. More number of hydroxyl group, more hydrogen bond can be formed between molecules, so higher will be the boiling point. So, and we look at the branching. So branching reduce the surface area in contact between molecules, weaker when the wall forces, lower boiling point. And we look at solubility in water. So for solubility in water, we have seen 2 factors affecting solubility in water. The first one, molecular weight. The second one, the number of hydroxyl group. So when molecular weight increases, means that the hydrophobic area increase, then solubility in water decrease. Okay, for number of hydroxyl group increases, more, so more hydrogen bond with water, so higher solubility in water. Okay, and the physical properties, we also look at the acidity. So acidity, must know that carboxylic acid most acidic because the conjugate base is more stable. The conjugate base, the negative charge on the oxygen can be delocalized between the 2 very electronegative oxygen atom. So there is resonance effect. So the the carboxylic ion most stable, so the most acidic, followed by phenol. So phenol less acidic than carboxylic acid, but again, the phenolside ion conjugate base is still stable by resonance effect, where the negative charge on oxygen can be delocalized into pi system of benzene ring. And then water, and the least acidic is aliphatic alcohol. So aliphatic alcohol, basically, it is not very acidic because the conjugate base is unstable. Why is it unstable? Because of the electron donating alkyl group made the alkoxide ion unstable. So there are the three physical properties of alcohol that you see today. And then you also look at the chemical test. So for chemical test, we look at for aliphatic alcohol, we look at Lucas test. So Lucas test for different classes of alcohol. Okay, so basically it's a substitution reaction where the Cl masuk ganti the OH. And for the Lucas reagent, make it cenderung kepada SN1. Therefore, tertiary alcohol, most reactive, you see solution, the cloudy solutions form immediately. Okay, followed by secondary alcohol, then primary alcohol. 10 minit tidak cukup. Okay, so you don't get the product. That is Lucas test. And for aliphatic alcohol, the chemical test, the second chemical test we look at is Iodoform test. So Iodoform test, basically we want to detect whether methyl carbinol group present. So this is methyl carbinol group. If there is methyl carbinol group present, then you get the yellow precipitate, the triiodomethane. So the second chemical test that we look at is for the phenol. So phenol, there are two as well. So test with FeCl3 solution. So you get purple complex. And then another one is test with bromine water. So you get a white precipitate of 2,4,6 tribromophenol. So basically, these are the things that I cover with you tonight. So that's it for tonight. So here is the QR code for the attendance, so you can scan and then answer some questions. And then that's it for tonight. So you all can say good night to Madam. Anybody want to say good night to Madam? Okay, good. So then that's it for tonight. So I will see you tomorrow for some of you. Okay, bye-bye.